That's why I can't hear. All right, welcome to Nested Loops. We are going to do the bridge pattern today, and joyfully presenting, and I emphasize the joy, will be Diego. Oh wait, did we want to ask? Did I write a note to answer questions from last time? I think we've ducked that the last few times. Plus, I can't find my mouse anymore. I think we were going to start this off. We have back questions, which I got to go and find my. Unfortunately, my keyboard's not responding. I need to find my Word doc. Not my Word doc. PDF. Oh, great. All right. See this working? Oh, great. All right. Well, we were going to ask questions for the 2 chapters before this. Which one is it?
Oh, yeah.
You know what page? But my game, I'm scrolling very slowly through it. It would be what, I think 8 and 9.
Do you mind sharing your screen with that?
I could, but I'm only up to chapter 5.
All right.
Since
no, like I have to find my document.
I have to scroll very slowly through this. Hold on.
Oh, I found it. All right, hold on.
All right. So, and I forgot who. Were you 8?
Yes.
All right. So I am like scrolling. There's got to be a. I have to say PDFs are not that handy. Facade. Okay, I'm up to chapter 7. Anyone happen to know what page we're going to? Commonality, I remember that. Strategy, okay. Was it, were you strategy? Or were you the one before it?
He was strategy.
You were strategy? All right. So then we wanted actually that and strategy. So we actually want questions for before strategy, right?
Yeah.
All right. Review questions. What? Since we're so far removed from previously, we probably don't remember any of the answers. What was the right way to think about encapsulation? That seems very general question without knowing what Al meant. I didn't know. What was he saying about encapsulation? Traditional way is limited, so we know that when expanded definition include any kind of high. Okay, I believe his answer was this, which he says encapsulation is any kind of hiding, which is kind of actually how I thought about it in the first place. So it's always one of those where it's like, oh, I didn't think it was so limited. By thinking of objects, encapsulation inheritance is limited. Encapsulation exists for so much more than hiding data. Hiding anything. Yes. Okay, sure.
Yeah, actually talks about it on the bridge pattern as well. Like most people think about encapsulation hiding data, where you can hide objects and implementations.
Yeah. Okay, 3 perspectives for looking at a problem. You may, oh, I remember. It's like the 3 general levels was like design, implementation, and something higher level, where it's like you can, which coincides with UML. You know, you can use UML just to hash out ideas at a very high level or a design level or a right down to the implementation kind of level. And he must emphasize this because apparently this is a problem for people. Being able to change your views or your perspective. There are 2 different ways to understand objects with data methods and things with responsibility. What way is the second superior to the first? What additional insights does it provide? I would think it's a higher level thing. It's more, I think, general. What makes that better is if you have things with responsibilities, you're not forced to drill down in the details. So you can think about what things do, which when you're thinking about design, single responsibility principle will help you. I just lost train. Yeah, make more coherent things. If you don't get lost in the weeds, you can think, oh, this is supposed to do these kind of things, interact with stuff that does that kind of stuff. And data with methods tends to be that lowest level that he's talking about, where it's so easy to think about datas and types and numbers that you lose track of what the big picture is. So that's kind of what I would think of it. I don't know if anyone has any contrary opinions. Can an object contain another object? Yes, of course it can. Is this different than one object containing a data member? I remember him making a deal about this, like, oh, you can include things that are not primitives. But again, I believe I mentioned that, since everything is an object, or just about everything is an object in Ruby, it's not a big mental shift, whereas like C++ or Java, where you have primitives versus objects, it might be a bit of a mental jump of, oh my God, it's not an integer. Yes, it's not an integer. Next one, find what varies and encapsulates it. All right, maybe someone else should answer this, because in my mind, find what varies and encapsulates it is self-explanatory. So I'll pick Andrew. Andrew being the most junior person in our team. What does that mean to you? And is it confusing? Andrew.
Can you hear me?
Barely.
If you can hear me, then encapsulation is about kind of, if I know that, I kind of want to say something like with families, but it's not really a family, but if I can swap out something pretty easily, like a hat, then I would make like an object called hat, and I can assign different attributes to it, but it would still respond to, hey, wear this hat, or buy this hat, or it's raining, go get your hat. Doesn't matter what kind of hat. But it has certain messages that I'll respond to without having to kind of hard code it in. I don't. Maybe my understanding of encapsulation isn't great.
That's okay, but the question is, what does the phrase "find what varies and encapsulate it" mean?
Oh, what changes?
Yes, the highlighted part of the PDF.
Find what changes.
I instead of say like just give an example of it. I think that's easier, because like you find yourself repeating the same sentence, right?
That's kind of why I say, what does it mean? It kind of means what it says it means. So
So-
I'm wondering if I have the wrong perspective on it.
Further up in it, it says the Gang of Four suggests the following. Consider what should be variable in your design. This approach is the opposite of focusing on the cause of redesign. Instead of considering what might force a change to a design, consider what you want to be able to change without redesign. The focus here is on encapsulating the concepts that varies a theme's many design patterns. So I guess it has to do with redesigns.
Yeah. I mean, it's when he says, what does that mean? Find what varies and encapsulate it. I'm with Diego. You basically say the sentence in a different order. I don't know what to say. That seems very straightforward. But
I think the process will be like to observe the classes that you have and try to figure out what they have in common, right?
Right.
And you branch a group by that, and everything else that is not in common is what varies. And then you can, by encapsulating, you can extract this something else.
Yes. So a good example, I think, is like a database. All databases have like, initialize or query, a certain category of things that are the same. But you can imagine, MySQL versus Oracle, the details are different. The commands, if it's via API, or even if they just shell into the command line, if you use the Postgres command line versus the MySQL command line, the commands are different. They're the same things, like show me all the tables. Well, it's show table semicolon in MySQL, and offhand, I don't recall it's quite what it is in Postgres. So you can see, oh, they do the same kind of things. And so if we look at the common commands, which, in each subclass we would put the specific thing to the database, then we should be able to easily add any other SQL database to Active Record. Active Record is a good example of that one. And to some extent, they've even taken non-SQL databases and made Active Record, what do you call it, wrappers, Active Record adapters for them, Mongo and whatnot. All right, explain the relationship between commonality, variability analysis, and the three perspectives of looking at a problem. All right, it's been too long since this chapter happened, so
What was the guy's name, though, that you said there was some guy?
Coplian? Jim Coplian, he's the guy that everyone refers to. He's got some big fat C++ book where he talks about this. But which oddly, as far as I can tell, it's about as much as he says in this book. Check Jim Coplian's book about this.
A YouTube video of him. It didn't have to do with encapsulation, but it was interesting. He seemed like he really wasn't a big fan of TDD.
Oh, I wouldn't be surprised. So I don't remember much being said about what this actually is, different than when I see the two words commonality and variability, it seems to match the previous sentence. Find what varies, i.e. what's not common, versus what does. And the three perspectives of looking at a problem. My assumption, the only thing I can infer from this is at the higher perspective, that's where you figure this stuff out.
So yeah. So the commonality gives you a conceptual perspective. I'm actually kind of looking at it. So conceptual perspective, which essentially you can derive the abstract classes, and combination of commonalities and the variability gives you a specification perspective, which kind of again allows you to separate what goes in the abstract classes versus the concrete classes, and only stuff that varies goes in the concrete classes. So those are the three perspectives we're talking about.
Yeah.
Like, so the variability, but the specification. Let me think about it. The conceptual is like hierarchical, like what kind of stuff I have. I have shapes, I have drawings, I have this, right? Specification is more like what is the full set of method and functionality that I'm gonna get out of this. And the implementation are like what are the specialized classes look like. Make sense?
Yeah. Cool.
So it's three ways of looking at things. If you're talking about cars, again, commonality is like, oh, we have cars, and more, specific way we would say, well, I have sports car and this kind of car, like SUV or whatnot, and then the implementation would be, well, the sports car has like a pedal shifter, and the other one has like a four-wheel drive kind of thing, which is like something that's specific to the concrete class. But they all, like again, at conceptual level, they all drive, they'll start, stop, turn on engine, turn left, right.
All right. An abstract class maps to the central binding concept. What does this mean? Boy, I don't remember those terms, but abstract class is really setting the interface that all the objects that will inherit from it will implement. So for example, like drive, start, that's something that all the cars do. So everything in that thing, again, I don't know about this word here, central binding concept, but it defines the category, the common responsibilities for all things under that hierarchy. Variability analysis reveals how family members vary. Variability only makes sense within a commonality. What does this mean? I'll just go back to database. Everything has initialize. You have to initialize a database, but the strings that you might send are different for each. So when we vary, they all do the same function, but they do the function differently. What types of objects are used to represent the common concepts? I don't know what that means exactly. What type of objects used to represent the variations? Okay, I think the common concepts is the abstract class, and the specialized classes is how you do the variations. So they all implement the same interface, but they do it differently. I think that's what this is talking about, unless someone disagrees. Jumping down to here. Why is it better to start focusing on our motivations rather than implementation? Give an example where this has helped you. It leads to a better design because you can think about how things fit together, and you can do things like this whole variability commonality thing, which will allow you to hopefully have a design that is resistant to change because you'll know up front what kind of things could change. Give an example where this helped you. I don't know, anyone? I'm sure it would happen. Or we could probably give examples where it didn't help us. So we went and did it, and we should have looked at the classes and realized, oh, this didn't change. This could have changed, but we hard-coded something that was hard. I don't have an example off the top of my head. I don't even have an example for the bad, but I'm sure I have one. It's Monday, sorry.
Well, I think if you focus on implementation, you fail to see like one thing that is like more the job that they're doing, right? And the commonalities.
Mm-hmm.
I think that's probably why it's better.
Yeah. Preconceived notions limit one's ability to understand concepts. This was shown to be the case with encapsulation. Can you think of a situation where your preconceived notion got in your way of understanding requirements? What happened and how did you overcome it? For this particular case, I can't think of it, but I see it a lot when I help people debug. Just in general, it's like I'll be helping someone debug, and they have this idea of how something's going to work or how it is working, and that's all they're looking for, and they don't see, well, you know, the reason this is failing is because, you know, this thing that you assumed is true is not true. And ultimately, you got to be very Sherlock Holmesian, and you just got to go where the evidence shows you. So some of that, and I don't know if this applies as much as far as, well, I think it does a little bit, but design is you got to really have no ego. A lot of people are wed to, this is my idea, it has to be right. I see that in debugging. I could see that happen in coding. Hey, this is the pattern I have to use. This has to be the right thing. Whereas the best way to look at things is really, you got to look at the circumstances and adapt to that one. And I mentioned again, like refactoring 2 patterns, which the reason I think that's such a good book is you look at what your problem is and you look at the pattern that helps you. And if you refactor to the point that you solve your problem, that's as far as you have to go. Because if you go further, you end up putting stuff that you don't need, and that becomes the decoy code that Scott likes to talk about in our project. Oh, here's code. It must be something. Well, no, it's just there. In some cases, because you decided to implement the full pattern instead of the part that helped you. So the answer that beginners don't like is everything depends. Always pay attention. There's no canned answers. But what happens is when you have the preconceived notion, you think it's got to be this way, or this is the only thing I know, so I'm going to do it this way. The whole, you only have a hammer, everything's a nail thing. All right.
I think sometimes it's just like, well, yeah, I'm not sure. Like, I know I've encountered this many times, like when I help, when I help somebody else debugging, and usually my question is, like, they come to me like, it doesn't work. I cannot get this to work, and my question is not why or what not. It's like, what are you trying to do?
Mm-hmm.
There's probably another way.
Yeah. Definitely, I have to establish the base.
Right.
What are you trying to do? What do you have, and what is happening?
Yeah, because
right.
I think like it happens quite often that you see. I'm having a hard time like. I don't see it as understanding the requirements, but understanding the system. Like generally, there's a preconceived notion of how the system works. That's not correct. So people get stuck.
Mm-hmm.
All right.
So, all right.
Are we gonna go through all of them?
In theory, we should do it at the end. The fact that we're doing it so long, I'll try to go faster. Inheritance, non-abstract, specialized. When abstract class is starting point, you better have two different terms. These the same term. Okay, so he's getting down to this is a nitty gritty that it never really bothers me, but apparently, if he's asking the question, it does. He wants to say inheritance uses when a class derives from a non-abstract class, and when an abstract is a starting point for different implementations. In my mind, it doesn't make a difference, but I don't know if I'm not the right audience. So, okay, we don't have to discuss too long. I don't know that that's because it's not a question to me. I don't know if it's that important, but I could be wrong.
Yeah, I can see the difference in them. I don't know, because like, potentially in one case you have like a inheritance for a dummy, like which is the abstract class, and one is like from actual some kind of implementation that does stuff. I don't think there's a need of personally.
Yeah, I don't see how you buy that much. I mean, it is a difference, but inherit from what you need to inherit from is kind of.
Oh, actually, no. One could be like in proper inheritance, and the other would be interface inheritance. If you wanted to, because that's what you're doing. Like in the abstract class, you're just inheriting the interface. I actually have like a different take on this. Once we get to it, like I'll talk about it.
Sure. How much you use commonality variability analysis to help you think about ways to modify a system? I know if you know what varies up front, then you can prepare for such things. I don't know. Some of these seem kind of redundant in my mind, but again, maybe I'm not the right audience. It is important to explore variations early and often. Do you believe this? Why or why not? I don't really have an opinion.
I think it's okay to no, don't do that. Turn that off, please. Jesus Christ.
All right. You do realize this is broadcast.
I can give myself like a with an echo. I cannot do it. Anyway, I think it's important to do it, to consider, although you would not want to start designing like based on the possibility of the system varying before you actually have variation. Unless it's something very, very simple to do. And the reason is you end up with pattern classes that you don't need, right?
Yeah.
Like we have something in our system that we can use an adapter pattern because we migrated from something to something else. And then once we moved and we were fine, I removed all those classes. And I just made like whatever that moved became the abstract class.
Yeah. All right, trying to bang these out. All right, so commonality, variability is an important primary tool for identifying objects, better than looking for nouns. Do you agree? I'll say yes.
Yes.
Because that's his whole point, is the old noun verb thing is not adequate. Chapter try to present a new perspective on objects to succeed. Why or why not? I'll go with Brett. Did Brett do that one? Or no, you did the next one. Scott did it. Scott did that one, right? I think if you didn't have that opinion, that perspective, maybe you did, because I kind of went into it with it. I already had it.
Yeah, I did this chapter. I thought, yeah, it helped. Yeah, I liked it.
All right, so now I'll go to the bottom of strategy. Blah, 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 blah. Strategy, field notes, summary. Question, alternatives for handling new requirements. All right, what were the alternatives for handling new requirements? Oh, well, I can only guess. Chapters about strategy. It's about encapsulating algorithms within a object. So is the method of to me, it's always the same message. Take what varies and encapsulate. So you can, and I think what defies the little noun verb thing is when you see some of the patterns that are really about encapsulating things that are not just objects, but like, in the case of strategy, or you're encapsulate or command. The command pattern is also encapsulating action, which is not, you think of it as a verb and not a noun. You can actually take verbs and encapsulate them as objects. And then you can swap them out because they're just objects. You throw a different object. So, in the case of strategy, you can have an algorithm that's like twice as fast, but they do the same thing. You can swap them out. And they have the same interface because of commonality, but the variability is they're faster or slower, or maybe more memory, less memory. So when I just look at it, in my mind, it's all the same thing. Oh, just take what varies and encapsulate as an object, which doesn't have to be just a noun. It can be verbs. So that's what I think this is. 3 fundamental principles guide how to anticipate change. I have no recollection at this time.
I personally think he meant a copy and paste.
Oh.
That's how you handle your requirements.
Okay. Yes, I'm sure. I'm sure that's what he wanted. All right. So does anyone remember what the 3 principles were?
Or how to anticipate change?
Yeah. What were the 3 principles by the Gang of 4? Who is the chapter presenter? Gang of 4, strategy.
I think it might be the same 3.
All right. It's okay. I'm not going to kill too long. I forgot no answer. What's the intent of strategy pattern? To encapsulate an algorithm so that you can swap them out. That basically does the same. Has the same results, but does in different ways generally. But actually, I've seen it vary to that one. But that's the basic pattern. What's the consequences? Complexity. There's always additional complexity at the cost of flexibility or sometimes design thing. That's the thing, is if you don't need a pattern, don't put them in place. That's kind of the mistake of like almost 80% of J2EE. It's just 9 million patterns that oftentimes you don't need it. You always get a thing that gives you an abstract factory. You got to get something that gives you an abstract factory so you can get a factory for something that you need, but it's always the same thing that you need. But you end up instantiating 3 objects for something. It's like, don't do that, that's bad. Now, strategy doesn't necessarily do that one, but if you only have one strategy and you're not going to have another one, then don't put the strategy pattern in.
Hey, by the way, I found the 3 things. Program to an interface, not implementation. Favor aggregation over inheritance.
Yeah.
And consider what should be variable in your design.
Okay. Yes, those are all good.
And encapsulate those.
Those are all
Once again,
good.
frame what varies and encapsulate is the 3rd one.
Yeah. All right. Gang of 4 suggests considering what should be variable. How is this different than focusing on I think this is how you should look at it at the first level, just looking at the kinds of stuff, right? And I think this allows you to have a more a bigger picture of how the system should work versus some narrow focus. This is the same reason I think you don't always want to focus on implementation first. You get like tunnel vision and you might miss important parts. That's about it, what I can think about. What's wrong with copy and paste? Duplication means you got to change it everywhere. Right? What is meant by switch creep? I'm assuming this is too many switch statements.
Yes.
To echo Java and C, all C-derived languages. Yes, this is. It's a smell that you probably need to extract a class out that you can go and change the subclasses. What is the advantage of design patterns, approach to handling variations?
But by the way, I think the switch creep is mainly the switch creep if it's based on the class, right? If it's like a switch, like you do if this class is this type of thing, if the class is that type of thing, you know, that kind of stuff, it's a switch creep. Or if you do, if this condition, do this, if that condition, do that. But there might be cases where huge switch statement is fine because it's nothing that has to do with different type of classes that have commonalities.
Yeah. Well, at some point you have to decide stuff.
Yeah.
So invariably, if you have a large hierarchy, there will be a switch somewhere. But the problem is the switch creep is, oh, I've got to change this switch, this switch, this switch. Okay, we added a new type. Oh, I got to change this switch, this switch, this switch, and this is.
Right.
Right, and that's what we're talking about, and that's bad, and that's a smell that you need a...
Like whenever you add a new abstraction, you have to add to the switch statement. That's
bad. That's part of the smell. I guess we should do refactoring after this, since we're talking about it so much.
Right.
That should be a good book. Advantage of design patterns, cleaner code, better changing. Why is object aggregation superior to direct class inheritance? Allows you to switch things out easier. You want to change the behavior in the child, you can switch it. Changing inheritance hierarchy can be more complicated. Also in C++, you have a diamond of death.
But you also are able to isolate what changes, right? In separate classes.
Yeah, that's good too. All right. Have you ever had a situation you felt you could not afford to anticipate change? What drove you that way, and what was the result? I think that's usually when you feel you don't have enough time.
Right.
Or you don't have the foresight to do it.
Yeah, generally it's time or too big of a project.
Yeah.
It's like so many things can change. It's like overwhelming, I think.
Yeah, and I think we discussed the switch thing. There's a time for a switch, but if you're changing 3 switches every time you add a class, that's bad. Okay, on to chapter 10.
Yeah, do it.
All right, so I'm going to unpresent.
All right. Where is this? Do I have everything showing there? Sure. How much do you guys see? All right, so the bridge parent. All right, so the bridge parent, the author starts with a definition from the Django 4, which is indeed a confusing definition. So apparently it talks about, the bridge parent is to decouple an abstraction from its implementation so that both the abstraction and the implementation can vary independently. And this is it is a fairly hard thing to understand, because generally the implementation, up until now, we always talk about the implementation of the abstraction, meaning you have some abstracted ideas, and there's an abstract class, and then you have a concrete classes. Concrete classes are the implementation of the abstracted idea in the abstract class. But in this particular case, the implementation is more than that. Implementation is not just the implementation of the abstract classes, but also any other object that is being used by your abstraction. So you can actually separate what your abstraction is, and so all the commonalities, and the objects that are used to express your abstraction might also have their own abstraction and implementation. Hopefully that makes sense.
No,
so, huh?
No, the bridge is a confusing pattern in general, so definitely sit and think.
So, and he talks about, he thought that implementation were a way to build the abstraction. So it's okay, let's go through the process and let's try to figure it out. So it goes with the example, and it goes back to the CAD-CAM problem, right? And let's see. So it's going to go and say, okay, the thing we're going to do, we're going to draw shapes, and they're going to explore all the possible variation, but as it goes along. So I have two different drawing programs, DP1, DP2. They have two different interfaces. One is like draw line, one word, draw a line, draw a circle, draw circle. The parameters are in different order. So right off the bat, we can see that chances are we're going to use an adapter pattern to unify and abstract these differences, because we can see that this is what changes in these two different systems: the order, the name. So we're going to have something there. We've gone through enough design patterns that we can kind of spot that one. So now we say, okay, let's use our inheritance, and we're going to know that we're going to have different types. We're going to have at least two different types of shapes. We're going to have rectangles and circles. So let's create a shape class that rectangle and circle can inherit from, and they're all going to implement the same draw thing. And then we're going to have the implementation side of it, which is when it draws, the thing that actually draws. So on the left, we have our abstraction, our concepts. And on the right, we have our implementation stuff. So how the thing on the left is going to actually do the work. So that now you already start seeing what the Gango for we're talking about. We're not talking about rectangle implementation of shape, but we're talking about specifically how when you call draw, what actually does the job. Like these other things that's changing outside of rectangle, circle, triangle, pentagon, all that kind of stuff. All right. So it pretty says, okay, by having an abstract class rectangle, we can actually, inside of this draw method, we can call the draw line from the drawing class or one of these methods, and pretty much we can say, okay, we're gonna have let's see if I can get to it, a version 1 that uses DP1, right? It's gonna call draw line, And version 2 is going to call drawLine on DP2, and circle is going to do the same thing. We can already see that this is a very simple implementation. Each implementation of this concrete class knows exactly how it's going to work. So when you call drawLine, V1 knows that it's going to use DP1, and V2 knows it's going to use DP2. Same thing for V1 circle, it's going to use DP1, V2 circle, it's going to use DP2. But not just that. Imagine there's a client here. The client that uses V1 rectangle knows whether it's going to use DP1 or DP2, right? And it doesn't care too much, but it knows about it. The other thing you can see from this is what happens if I add a triangle shape. I'm going to have another class here. I'm going to have 2 implementation on it. And now we increased by like a 3. So we started with 6. Now we got 9 classes. And if I add a DP3, it all multiplies. So it's not a great solution. Like this solution, just by using inheritance, is gonna pretty much explode the classes, the number of classes you have every time you add either a shape or a printer to see, or a system to print out of it. I'm gonna go forward. Yes, the project, it shows like an implementation of it, and then it shows like a sequence diagram. And the next page is explaining how the sequence diagram works. So you have a client that calls draw on an instance or a V1 rectangle. Draw calls on itself, draw a line. Draw line calls to V1 and doesn't return. Then it draws the second line. It calls on the points to draw the second line. It calls on itself, draw line again. Again, it calls on itself because this V1 rectangle, in a way, is implementing a poor man adapter path, right? It calls a method internally that translates to what DP1 is. And if we look back up, it's because the method rectangle has a draw line, which called a private method draw line like 4 times. Everybody following at this moment?
I am, but I'm not really.
Andrew? Huh?
Text message.
All right.
Is this a setup of a good design or an option?
I cannot hear you.
Is this the setup for a good design or a not so good design? Is this a setup for a good design or not so
No, not good design.
Okay. That would make more sense.
Right. Yeah. No. It's saying like this is like a first crack at it without not knowing anything about. Okay. Like I'm gonna do an implementation using a very simple thing, but it shows how poorly it scales. Right. So like I know I'm gonna have a draw. This is my public interface draw. Internally, you have a draw line, a draw circle, but because I got the system, I need to have specific implementation of each. All right. So again, like this, when I have a view VR1, I'll call draw, which call draw line 4 times, which translates to DP1 draw line. And so like I got this like 9 calls internally of my own object. And we can see that actually have 3 objects represented. The client, which is the rectangle, and DP1. So in a way, it's a very simple design because you only have 3 classes. And here, apparently, it discusses how to read a sequence diagram. Let me see. So it says essentially this solution suffers from a combinatorial explosion, which I discussed. That if you add more shapes, you multiply however many shapes by the time of output system that you have. And if you add output system, you multiply the output system times all the shapes. And that is because of that coupling. So, so eventually it talks about that, does it look to ask yourself about this? Is there redundancy? Would you say you have strong cohesion or weak cohesion? I think tightly coupled or loosely coupled. And if you look over here, going back up, how often do you specify draw a line? Right? Twice. How often do you draw a circle? Twice, actually, and 3 times. So they say, okay, let's try something different. And primarily, it talks about and all that is due because of being tightly coupled. Now he also talks about all of this happens very often because there's over focus on the isness of object. This object is a something. A rectangle is a shape, and you cannot stop there more than, and you don't think about has a, which you're gonna eventually get, like has a output system, right? So it comes up with a different implementation. To say, well, what if I have shapes, right, that they draw, and I have like a V1 shape and a V2 shape. They each system have like have like a draw line, draw a circle, again V2 draw line. They each talk to its own system, and then the specific shapes inherit from that one. Okay. Design like this is actually a little bit cleaner, right? You don't see a lot of cross arrows and all that kind of stuff, but it's still a bad design. It's like it's not really a lot better. It's just better in a different way. So let's imagine what happens if you add one more shape. Or let's say one more system. So you have DP3. You pretty much you're gonna have to duplicate the whole hierarchy. And if you add a new shape, again, it multiplies across the board. So you didn't gain anything. So you have multiple implementation of rectangle, multiple implementation of circle. When in reality, they all kind of do the same thing, right? Like a rectangle goes from point to point to point to point to point. So since it does this, all the circle, all the rectangle do kind of the same thing. Why do they need to be defined multiple times? And it goes back to say, okay, this is the secret diagram for this other thing. Nothing has changed. All right. Hold on. It says it still has scaling problems. it may be an improvement of the original solution, and still has problem with scaling. And by the way, I've done plenty of solutions just like this. And it took me a while to figure out how to fix them afterward. So, and then he talks about, okay, let's look at a new, different way to do it. And so if you actually know, so right now you kind of know that you have two different systems or two different ideas in this problem. You have the shapes and the outputs, right? And if you kind of know the definition of a bridge paradigm, you say, if you already knew what a bridge paradigm is, you say, oh, this might be a good use for bridge paradigm because I have two different things that are related to each other, they kind of talk to each other. They are both going to change, or they can change, and if they do, they probably will do dependently on each other, which is the definition of the bridge paradigm. You have an abstraction that can change, and implementation that can change. So you go, okay, how do we go about deriving? And again, he talks about, I think he actually explained this before. There's a solution that have reported several problems, and they have therefore proven themselves over time to be good solutions. And again, he talks about deriving them and not coming up with stuff. They say, oh, this is a solution that have worked in the past. And they've been demonstrated in at least 3 independent cases that they work. Which is kind of, you know, I've talked about a few times about the rule of threes. If you have a solution that works for 3 different things, you probably got a pretty good solution. And there can be like a specific interface of a class or API. If it works, you get like a 3 implementation of it, and they all work good. You cover most of your problems. So again, it goes with Jim Confident's work, which pretty much is like find what varies encapsulated and favor aggregation over inheritance. Again, and these are like, based on what we just saw before, 2 of the 3 King of 4 directives. The first one was design to interfaces, not implementation. All right, so again, let's try it. Identify what's varied, and what's not. So we have 2 different ideas, shapes and drawings. And I will not call this drawing, but some kind of output or something, but drawing is probably good. So you got shapes, which are going to be rectangle, circle, triangle, whatnot. And drawings, which are, you know, could be like a, different plotting, different machines, printer, drivers, or whatnot. And so like what's varying are like a different implementation of these 2 concepts that are tied to each other. So this diagram actually is identical to what we had before. But from this, we're going to go, instead of creating inheritance, V1, V2, rectangle, V1, V2, circle, we're going to go in a different direction. We're going to say the shape has a drawing. And actually, you got these 2 different things. So you can either go a shape has a drawing or a drawing has a shape, right? And then you kind of need to figure out which one feels correct. So, and over here it talks about if a drawing programs could draw shapes directly, they will have to know something about the shapes in general, what they are, what they look like, and it violates a fundamental principle of object. An object should only be responsive for itself. So, like, drawing, if he knew about shapes, he might actually have to know how to draw a rectangle or how to draw a very specific type of shape. Now, if a shape has a drawing, all it really needs to know is that it can draw a line, draw a circle, right? All right, so let's see. The shapes uses drawing to manifest this behavior, and underneath over here, there's like one more thing, which is the translation of draw line to the DP1 method, translation of it to drawing to DP2 method. And we almost out of time. So we have a shape abstraction and a drawing implementation. And to me, I understand this is how they decide to do it. So in a way, like what this is like, again, the difference between implementation and abstraction. And is that like we come up with these ideas, but they're in our heads, right? While the DP1 and DP2 are actual implementation of how to do stuff. So I think it goes, again, like there are two levels of implementation, or when you say separates things from implementation. And part of it has to do the implementation of your design, of your abstraction is one thing, but also implementation of what your abstraction do is this other implementation. I guess it's an overloaded word in a way. And the thing about here is that it kind of shows that right now there's only one place where you implement a rule. Meaning, when you draw a rectangle, you go from corner to corner to corner to corner to corner, right? And right now, that rule is specified only there, right? When you instantiate a rectangle, you say, this is a rectangle with this, top left corner, bottom right corner, right? And you're gonna paste in a drawing, you say draw. And before, we had the corner to corner to corner to corner in multiple classes. Now it's only one class. Circle, same thing. It's just one class, no multiple. Also, in the previous cases, each one of those classes was doing the translation from draw line to draw a line and stuff like that. So pretty much, and so like it goes to say, now it has a better understanding of implementation, which is something outside of my object that is used by the object of my abstraction. And so, again, a client, it kind of looks at all the different objects. So a client only knows he has a shape, the client of the class. Now, when I get a rectangle, I know that it's a shape, but I really don't care if it's a rectangle. I might not even know whether it's a rectangle or not. And actually, I don't even know what output does it have. So it's a rectangle, circle, the client cannot tell. Now, The rectangle has a handle on the drawing, which is a V1 drawing or V2 drawing. Again, the shape doesn't know. It doesn't care because they have the same interface. And now the drawing is the only thing that knows DP1, DP2 because it's doing the translation, right? So like it shows like the whole implementation. And one of the things they it talks about pretty much like, in retrospect, bridge pattern has a couple of different things, as an abstraction part and as an implementation part. And in this case, and as quite often it happens, there is, because you have things that change on the implementation part, you end up having a combination of pattern of patterns. While it's not necessary and not always the case, you quite often end up having an adapter pattern implemented inside of bridge pattern, because that's generally what changes.
All right, let's wrap this around here. I think we got to go back and look at this design because it takes time to digest this.
Yeah.
So I think if we pick up again after 2 weeks of digesting, and maybe even go back to the design and why it's better, I think it'll sink in. It takes it. God, I've seen it before, and I look at it again and go, shit, I forgot how this stuff works.
There was a couple of things that I wanted to point out. I was trying to get to it.
Well, okay. Make yourself a note and pick it up. We're kind of over.
All right.
Yeah.
So one of the things is like some of this stuff, and actually talks a little bit about when he talks about C# and Java, and C++. The language kind of dictates what these classes are. So like you say in C# and Java, shape and drawing are going to be abstract classes. In C++, these are going to be kind of a concrete, like an abstract class, but it actually has behavior. And the thing I was thinking is like in Ruby, you don't even need those classes. But they're nice to have because they kind of explain how you group the concepts. So you don't need an abstract class in Ruby. But if you see these things are inheriting from something, you know when you edit the code that they all kind of do the same thing. I mean, you might group it in a different way. Maybe you put them inside of a module. It might not do this inheritance at all.
All right, till next time.
All
right, thank you. We'll pick back up at the solution for the bridge pattern because that's where we are. And digest and think. Think about this. I know Andrew doesn't understand this. It's like, I've seen it before and I have to remember this. So think about this and let's try to absorb that. All right, thank you and enjoy your day.
The words are